Welcome back to the test session today. In the previous session, we learned one of the network optimization problems, which was called single source shortest path algorithm, or it was solved actually using Dijkstra's algorithm. Now we will be looking into another problem called the all pairs shortest path problem. Right? This problem is solved using Floyd's algorithm. This Floyd's algorithm is also called Warshall Floyd's algorithm because of a very simple reason. The initial method of solving the problem or the idea behind solving the problem was not for the shortest path but for the connectivity, right? The connectivity between any two nodes was being tested using Warshall's algorithm. Later on, Floyd improvised this algorithm to handle weighted networks as well. Therefore, this algorithm, because basically it was designed by Warshall and later improvised by Floyd's, in few places you also find the reference to this algorithm as Warshall-Floyd's algorithm, right? So shall we move on to the problem? So finding all pairs shortest path. What do you mean by all pairs shortest path? In single source shortest path, what we did was one of the node was considered as a source node, and from that node to all other nodes we were finding the shortest distance. But in this particular problem, what we try to do is between all the pairs, if at all you have three nodes in the network, let me say node 1, 2 and 3, then we will be interested in finding the shortest distance between all the pairs, 1 to 1, 1 to 2, 1 to 3, then 2 to 1, 2 to 2, 2 to 3, 3 to 1, 3 to 2 and 3 to 3, right? Between all the pairs we are interested in finding the shortest path. That is what is written here. Just have a look. Assume G is equal to V comma E is a network. So a network with a collection of edges and nodes such that C of V comma W is greater than equal to 0, where C is a matrix of edge costs, that is the cost adjacency matrix. Find for each pair V comma W the shortest path from V to W, right? Between all the pairs for the entire elements in the matrix, we are supposed to find out the shortest path, right? So obviously this will be a generalization of your Dijkstra's algorithm. In Dijkstra's algorithm, from one source to all other destinations we were finding the shortest path, but now we are finding the shortest path from all sources to all destinations, right? So the basic idea behind Floyd's algorithm is for any pair of nodes I to j, right, in the cost adjacency matrix, C of ij will be a value if at all there is an edge between I to j. If at all I to j does not have an edge or does not have a link, then we initialize it to infinity, right? So in the cost adjacency matrix, if an edge exists, you will have integer value. If you don't have edge, then you will initialize it to a value called infinity. Clear? So A is the cost adjacency matrix. We would uh, consider only the direct paths in the cost adjacency matrix. The first level cost adjacency matrix, we would be noting only the distances or the weights for direct edges that we have, right? to find the shortest path between all the pairs, what we do is we make use of the cost adjacency matrix A, and we try to find the next matrix A2. We don't call it A square, we call it A2. So here we are trying to find out all possible shortest paths between any pair of nodes with one with two intermediate nodes, right? So from A we find out A1, from A1 we find out A2, from A2 we find out A3, then from A3 we find out A4, so on, right? If you have four nodes, then the possible matrices that you will get is the initial matrix A, which is the cost adjacency matrix, which will involve only direct paths. Then you will get A1. This indicates the shortest paths using 1 as the intermediate node. Then A2, here we will consider using 1 and 2 as the intermediate nodes. Then A3 will give all shortest paths using 1, 2 or 3 or all of them as the intermediate nodes. And A4 will give us the final solution where all the nodes can act either as source and destination or intermediate nodes. So this is the basic idea behind the Floyd's algorithm. So the Floyd's algorithm makes use of your cost adjacency matrix, which is an n cross n matrix, right? And each time what we try to do is, if we'll set A of ij is equal to C of ij, which is the cost for all I comma j, and if I comma j does not have an edge, then we initialize it to infinity. And if at all we have I comma I, which is representing a self loop from 1 to 1 or 2 to 2 or 3 to 3, so on. So for that we will put the value to be 0. So all the self loops are assumed to be 0 in cost. Then from one stage to the next stage, from A to A1, the computation goes like this. A1 of ij will be minimum of A of ij compared with A of ik plus A of kj. So assuming the kth node as the intermediate node, from I to k and k to j, if at all I am traveling, what is the total cost or the total distance? I'll compare it with the direct distance. Whichever is smaller, that I will enter into the new matrix, right? This is the basic idea behind your Warshall Floyd's algorithm or Floyd's algorithm. So here, so just have a look. From 1 to 3, the direct path was 5. So if at all I am looking for, let me consider 1 to 2. So from 1 to 2, the best distance in the cost adjacency matrix was 8, because it was considering only the direct path. But when I consider 1 as the intermediate path, no change in 8. When I consider 3 as an intermediate path, what happens is from 1 to 3 the distance is 5, from 3 to 2 distance is 2. 5 plus 2 becomes 7. When 7 is compared with 8, 7 is smaller. So the matrix will be updated as from 1 to 2, the distance 8 will be removed, and in that place we will put the cost as 7, because A of ij is greater than A of ik plus A of kj, right? So based on that method, we would update the costs in the Floyd's algorithm. So if at all you want to have a look at the algorithm is very simple and very easy, right? Initialize A of ij is equal to C of ij, and for all A of I comma I, that is the principal diagonal elements, are representing the self loops, A of I comma I is equal to 0. Then for k is equal to 1 to n, for I is equal to 1 to n, for j is equal to 1 to n, three for loops, three levels of for loops. In the for loop, I am checking if A of ij is greater than A of ik plus A of kj, then A of ij is equal to A of ik plus A of kj. Whichever is the smallest value, that will be stored in A of ij. Fine. That is the algorithm for Floyd's. So the complexity, obviously, because I am using three for loops, one inside the other, the complexity will go up to big O of n cube. So how do we solve this problem? Algorithm is fine. We understood the algorithm. How do we solve this problem? So for this, I have devised a particular technique, which I call it as the key triangle technique. So for every element in the matrix, I draw a triangle. On the left side, I represent A of ik value. On the right side, I represent A of kj value. And on the base, I represent A of ij value. So now I add up the sides, A of ik plus A of kj, and I compare it with the base. Add the sides, compare with the base. Whichever is the least value, that will be your new ij, A of ij value. Right? A of ij is equal to minimum of A of ij compared with A of ik plus A of kj. So add the values on the sides and compare with the value on the base. Whichever is the minimum value, that becomes your new A of ij value. Clear? So this is the basic logic I would be using. So we will have a look at one or two problems so that you will be able to understand the procedure of solving the problem better. So first I will take this particular problem. How many nodes are there? 3 nodes. So in the graph given, I have, or in the network given, I have 3 nodes, 1, 2 and 3. So first I will construct the cost adjacency matrix for this, and I will call this cost adjacency matrix as A. So 1 to 1, because it is A of I comma I, it will be 0. Then 1 to 2, there is a direct path, so 8. 1 to 3, there is a direct path with 5. 2 to 1, there is a direct path with 3. 2 to 2, principal diagonal element 0. 2 to 3, there is no direct path, so infinity. Then 3 to 1, there is no direct path, infinity. 3 to 2, there is a direct path, 2. 3 to 3, principal diagonal element, so I put a 0. Fine. So the cost adjacency matrix is prepared. Now using the cost adjacency matrix, I am supposed to improvise the solution. In how many steps I will be improving it? See, the number of steps involved in solving the problem will depend on the number of nodes present in the network. So I have 3 nodes here. So I will have to solve the problem in 3 steps. Step 1, step 2, step 3. Fine. So we will have a look at it. Step 1, I will consider the k value as 1. So this is I, j and k. So k is equal to 1. So for all the triangles, see, if at all I have a 3 cross 3 matrix, I will have to put 9 triangles. So top represents the k value. So I put 1 for all the triangles. Then left side represents I. Right? See, in the key triangle I have written left is I, top is k, right is j. So K value for the first step, for all the triangles it is 1 top. Left represents I. So I, for every row it will be the same. First row I is 1, 1, 1, 1. For the second row 2, 2, 2. For the third row 3, 3 and 3. Then this is J value. This changes in every column. So for the first column 1, 1, 1. For the second column 2, 2, 2. For the third column 3, 3 and 3. Now I am supposed to put the values of, this is A of ik, right? Left side represents A of ik, 1 to 1. So 1 to 1 is a 0. Here it is 2 to 1, 3. 3 to 1, infinity. So one thing that you observe is the left hand side value will be the same in each row. So 0, 0, 0, 3, 3, 3, infinity, 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 right? The prominent or the highlighted column that you have got. So that will be the left hand side values. Now coming to the right hand side, it will be the same for the column wise. So this is 1 to 1, 0, then 1 to 2, 8, 1 to 3, 5. Okay, so this will be copied column wise. See, if you have a look, 0, 0, 0, 8, 8, 8, 5, 5, 5. So left hand side, right hand side both done. What about the base? Copy the entire matrix as it is. For the first triangle 0, second triangle 8, third triangle 5, fourth triangle 3, fifth triangle 0, sixth triangle infinity, seventh triangle infinity, eighth triangle 2, ninth triangle 0. So whatever the matrix that I have, I just copy it as the base values. Now the procedure, key triangle method. Add the sides, compare with base. 0 plus 0, 0 compared with 0, which is minimum, 0 only. So I write a 0 here. 0 plus 8, 8 compared with 8, 8 only. 0 plus 5, 5 compared with 5 remains 5. 3 plus 0 compared with 3 remains 3. 3 plus 8 compared with 0 remains a 0. 3 plus 5 compared with infinity. So 8 is less than infinity. So I'll write 8 here. Then because it is modified, I am writing it in a different color. But when you are writing, you can just put a circle around this because this is a modified value or changed value. Earlier it was infinity, now it has become 8. So coming to the next row, infinity plus 0 compared with infinity remains infinity. Infinity plus 8 compared with 2 remains 2. Infinity plus 5 compared with 0 remains a 0. So the first step is done, where we have considered k is equal to 1. By using 1 as the intermediate node, I have got all the shortest distances and I have called this matrix as A1. Now step 2, I'll consider k is equal to 2. All the top values will be 2, 2, 2, 2, 2, 2, so on. Ij values doesn't change. I 1, 1, 1, 2, 2, 2, 3, 3, 3 row wise. J value column wise 1, 1, 1, 2, 2, 2, 3, 3, 3. Okay. Now as you saw, left hand side will be the highlighted column 802. Copy it, 8 and 8 on the left hand side, 0, 0, 0 on the left hand side, 2, 2 on the left hand side. Now highlight the second row, so that will become the right hand side. 3, 0, 8. Copy it to the next row as well. 3, 0, 8. Copy to the next row. 3, 0, 8. Now all the base values 0, 8, 5, 3, 0, 8, infinity 2, 0. See here the input matrix will be A1. Should not consider A. See, for the first step, input was A, we got output as A1. For the second step, input is A1, the result that we will get will be A2, right? Now after putting all the values on the triangles, perform the computation. 8 plus 3 compared with 0, 0. 8 plus 0 compared with 8, 8. 8 plus 8 compared with 5, 5. 0 plus 3 compared with 3, 3. 0 plus 0 compared with 0, 0. 0 plus 8 compared with 8, 8. 2 plus 3 compared with infinity. Here I get a change. 2 plus 3 is 5. 5 is less than infinity. So I write a 5 here. Okay. 2 plus 0 compared with 2, 2. 2 plus 8 compared with 0, I get a 0. So in this step, this one value got changed. Earlier, 8 was changed in the first step. Now in this step, 5 got changed. So this will act as an input for the next step, for step number 3. So step 3, k values are 3's. So on top, all 3's will be written. I value for the row it is 1, 1, 1, 2, 2, 2, 3, 3, 3. For the column wise, j value will be 1, 1, 1, 2, 2, 2, 3, 3, 3. Right? So now left hand side will be highlighted column 580. So 580 will be written on the left hand side. So copy it 580, 580 on the left hand side. Now what about the right hand side? It will be the highlighted row 520. So 520 on the right hand side. So copy it as it is 520, 520. What about base? The matrix as it is 0, 8, 5, 3, 0, 8, 5, 2, 0. Okay. After writing the entire thing, the resultant will be matrix A3. So find it out. 5 plus 5 compared with 0, 0. 5 plus 2 compared with 8. 5 plus 2 is 7, and compared with 8, 7 is minimum. So 8 will be replaced with 7 here. So this becomes a 7. So 5 plus 0 compared with 5, 5. 8 plus 5 compared with 3, 3. 8 plus 2 compared with 0, 0. 8 plus 0 compared with 8, 8. 0 plus 5 compared with 5, 5. 0 plus 2 compared with 2, 2. 0 plus 0 compared with 0, 0. So I get A3 as 075308520. So this is my final result. So the final solution is 1, 2, 3, 1, 2, 3 matrix. Oh, sorry, this is not A4, A3. So it is 0753085 and 520. So whichever is the highlighted value, it is not representing direct path, it is representing an indirect path. For that, I'll have to write the path. So A12 value is 7. Sorry, typing mistake. This is not 5, this is 7. A1 to 2 with 7. So the path is 1 to 3 and 3 to 2. So 1 to 3, 3 to 2. A23 is a modified value with value 8. So the path is 2 to 1, 1 to 3. 2 to 1 and 1 to 3. Fine. Next, a of 3 1 is a modified value with value 5, so it is 3 to 2 and 2 to 1. Okay, any doubt with this? Is the concept fine? Right. So shall we move on to another problem? So this time I'll take a problem with 4 nodes. So how many steps I'll have to do? 4 steps. So in each step, how many triangles I'll get? Because the matrix is a 4 cross 4 matrix, I'll get 4 into 4, 16 triangles. Okay. So looking at the diagram, I have created the cost adjacency matrix. The cost adjacency matrix A is 0, 8, infinity, 1, infinity, 0, 1, infinity, 4, infinity, 0, infinity, infinity, 2, 9, 0. Okay. Now, step 1, k is equal to 1. All the top values will be 1. First row 1, 1, 1, 1. Second row 2, 2, 2, 2. Left hand side 3, 3, 3, 3. Third, fourth row 4, 4, 4, 4. Column wise, first column 1, 1, 1, 1 on the right side, 2, 2, 2, 2 on the right side, 3, 3, 3, 3 on the right side, and 4, 4, 4, 4 on the right side. Now highlighted row, highlighted column will be the left hand side, 0, infinity, 4, infinity. So copy it as it is, 0, infinity, 4, infinity, 0, infinity, 4, infinity, 0, infinity, 4, infinity. Coming to the right hand side, it will be the highlighted row, 0, 8, infinity, 1, 0, 8, infinity, 1. Copy it as it is, 0, 8, infinity, 1, 0, 8, infinity, 1, 0, 8, infinity, 1. Now base will be the input matrix, 0, 8, infinity, 1, infinity, 0, 1, infinity, 4, infinity, 0, infinity, infinity, 2, 9, 0. Now perform the computation. 0 plus 0 compared with 0, 0, 0 plus 8 compared with 8, 8, 0 plus infinity compared with infinity, infinity, 0 plus 1 compared with 1 remains 1, infinity plus 0 compared with infinity remains infinity, infinity plus 8 compared with 0 remains 0, infinity plus infinity compared with 1 remains 1, infinity plus 1 compared with infinity remains infinity, 4 plus 0 compared with 4 remains a 4, 4 plus 8 compared with infinity, 4 plus 8 is 12, 12 is less than infinity, so I am updating it as 12. Then 4 plus infinity compared with 0 remains 0, 4 plus 1 compared with infinity, 4 plus 1 is 5, 5 is minimum, 5 is less than infinity, therefore I am updating it with 5. Then 0 plus infinity compared with infinity remains infinity, infinity plus 8 compared with 2 remains 2, infinity plus infinity compared with 9 remains 9, infinity plus 1 compared with 0 remains a 0. So two values are updated here. This acts as the input for the next step. So k is equal to 2. You know how to draw the triangles and name the sides. So left hand side will be the column, highlighted column, infinity, 0, 12, 2. 8, 0, 12, 2. 8, 0, 12, 2. So copy it as it is, 8, 0, 12, 2, 8, 0, 12, 2, 8, 0, 12, 2. Now left hand side is done. Coming to the right hand side will be the key row entry, infinity, 0, 1, infinity. So copy it as it is, infinity, 0, 1, infinity, infinity, 0, 1, infinity, infinity, 0, 1, infinity. So left hand side, right hand side done. What next? Base values. The base values will be the matrix as it is, 0, 8, infinity 1, infinity 0, 1, infinity 4, 12, 0, 5, infinity 2, 9, 0. So now perform the computation. Infinity plus 8 compared with 0 remains 0. 8 plus 0 compared with 0, or sorry, 8 plus 0 compared with 8 remains 8. 8 plus 1 compared with infinity, 8 plus 1 is 9, which is less than infinity. So I'm updating it with 9. Then 8 plus infinity compared with 1 remains 1. 0 plus infinity compared with infinity remains infinity. 0 plus 0 compared with 0 remains 0. 0 plus 1 compared with 1 remains 1. 0 plus infinity compared with infinity remains infinity. 12 plus infinity compared with 4 remains 4. 12 plus 0 compared with 12 remains 12. 12 plus 1 compared with 0 remains a 0. 12 plus infinity compared with 5 remains a 5. 2 plus infinity compared with infinity remains infinity. 2 plus 0 compared with 2 remains 2. 2 plus 1 compared with 9. So 2 plus 1 is 3. So obviously 3 is smaller than 9. Therefore I update it with 3. 2 plus infinity compared with 0 remains a 0. So this is how you get the matrix A2. Now using A2 as input, we are supposed to compute A3. That will be step 3 of solving the problem. So you know how to draw the triangles. The left hand side will be the highlighted column 9103. So copy it as it is 9103, 9103, 9103. Next, right hand side will be the highlighted row 41205. So 41205. Copy it as it is 41205, 41205, 41205. So left hand side, right hand side values are written. Now what next? Base values. The base values will be the matrix as it is. It will be 0891, infinity 01, infinity 41205, infinity 230. Now perform the computations. 9 plus 4 compared with 0 remains a 0. 9 plus 12 compared with 8 remains 8. 9 plus 0 compared with 9 remains 9. 9 plus 5 compared with 1 remains 1. 1 plus 4 compared with infinity. So 1 plus 4 is 5. 5 is less than infinity. Therefore, I update this as 5. So 1 plus 12 compared with 0 remains a 0. 1 plus 0 compared with 1 remains 1. 1 plus 5 compared with infinity. 1 plus 5 is 6, which is less than infinity. Therefore, I am updating this as 6. 0 plus 4 compared with 4 remains 4. 0 plus 12 compared with 12 remains 12. 0 plus 0 compared with 0 remains 0. 0 plus 5 compared with 5 remains 5. 3 plus 4 compared with infinity. 3 plus 4 is 7. When compared to infinity, it is less. So therefore, I am updating this value as 7. Then 3 plus 12 compared with 2 remains 2. 3 plus 0 compared with 3 remains 3. 3 plus 5 compared with 0 remains a 0. So the resultant matrix A3 is 0891 5016 41205 7230. So this will be the input for the next step, step 4, where k is equal to 4. So you know how to draw the triangles and name the sides. Now the left hand side will be the highlighted column. So highlighted column is 1650. So 1650. Copy it as it is. It becomes 1650, 1650, 1650 for all the triangles. Then the right hand side will be the highlighted row 7230. 7230. Copy it as it is for every row 7230, 7230, 7230. Right? Now all the left hand side and right hand side values are written. What next? we are supposed to write only the base values. The base values will be the matrix as it is. So it will be 0, 8, 9, 1, 5, 0, 1, 6, 4, 12, 0, 5, 7, 2, 3, 0. Now perform the computation. 1 plus 7 compared with 0 remains a 0. 1 plus 2 compared with 8. 1 plus 2 is 3. When compared to 8, it is less. Therefore, I am updating the value as 3. Okay. Then 1 plus 3 compared with 9. So 1 plus 3 is 4. 4 compared with 9 is minimum. So 4 is updated here. So 1 plus 0 with 1 remains 1. 6 plus 7 compared with 5 remains 5. 6 plus 2 compared with 0 remains 0. 6 plus 3 compared with 1 remains 1. 6 plus 0 compared with 6 remains 6. 5 plus 7 compared with 4 remains 4. 5 plus 2 compared with 12. 5 plus 2 is 7. 7 when compared to 12. 7 is minimum, so update this value as 7. So 5 plus 3 compared with 0 remains 0. 5 plus 0 compared with 5 remains a 5. 0 plus 7 compared with 7 remains a 7. 0 plus 2 compared with 2 remains a 2. 0 plus 3 compared with 3 remains a 3. And 0 plus 0 compared with the 0 remains the 0. So the final output value A4, final output matrix A4 is 0, 3, 4, 1, 5, 0, 1, 6, 4, 7, 0, 5, 7, 2, 3, 0. Right? Only wherever I have written the highlighted values, for that we would be getting an indirect path that I am supposed to write. A1 to 2, A1 to 2 with value 3. So 1 to 2, I am going from this path 1 to 4, 4 to 2. So 1 plus 2 gives me a 3. Okay. From 1 to 3 with value 4. 1 to 4, 4 to 2, 2 to 3. So 1 plus 2 plus 1, I get a 4. So this is the indirect path, shortest path. So A of 2 to 1, from 2 to 1, I am traveling from 2 to 3 and 3 to 1, right? 1 plus 4, the value is 5. Okay. Then A of 2 to 4, from 2 to 4, I am supposed to travel. So the path is 2 to 3, 3 to 1, 1 to 4. So 1 plus 4 plus 1. So distance will be 6. Okay. Then A of 3 to 2 with value 7. A of 3 to 2. 4 plus 1 plus 2. That is 3 to 1, 1 to 4, 4 to 2. Okay. Then A of 3 to 4 with 5. A of 3 to 4 with 5 will be 4 from here and 1 from here. So 3 to 1, 1 to 4. Okay. Then A of 4 to 1 with value 7. A of 4 to 1 with 7 will be 4 to 2, 2 to 3, 3 to 1. So it will be 2 plus 1 plus 4, 7. Okay. Then A of 4 to 3, direct path was 9, but I am finding an alternate path with distance 3. So 4 to 2, 2 to 3. So 2 plus 1, 3. Right? These are all the shortest paths. Any doubt with this problem? All pairs shortest path? Hope you have understood the concept very clearly. One thing that I would suggest is, after listening to the video, once again play the video along with me telling it out. You parallelly solve the problem so that you will understand it far more better. Thank you for your patient listening. If at all you have any doubts, you can post it on the classroom platform. Thank you. Have a nice day. Enjoy. We'll meet in the next session. Thank you.